You see the essential parts of any C program. In this video, we will learn how to get prime numbers less than a given number. Let us see. For that, I declare four integers I, j, num, count, and also I am giving it a initial value 0. Thereafter, you know, we have to find the prime numbers less than the given number. So there may be several prime numbers. So for that we use the for loop. I equals to 2 because 2 is a first prime number, so we start from 2. And we have to keep this less than or equal to the given number. Suppose given number is num, so I have typed num here. And also you know that this given number must be scanned. For that I type printf function to show the user to enter that number, to enter that given number. Yes, this printf function will show the user to enter the number, and thereafter as soon as the user enters the number we have to scan that so that the C language can work on that. So percentage and its num is to be scanned, so ampersand num. Thereafter I type again the printf function to show the user what are the prime numbers less than that given number. So to create a new line I typed here \n. Thereafter I am writing the text, the prime numbers less than or equal to %d, comma, percentage is a format specifier, you know, and this stands for the num. And thereafter we work for this for loop. So for example, suppose 6 is a given number, then there will be 2, 3, 4, 5 less than 6. But 2, 3, 4, 5, these 4 are not prime numbers. Among these 4, 2, 3, 4 and 5, 4 is not a prime number. So you have to check every number whether it is a prime or not. For a number to be prime, there must be only 2 factors. So for that I again use to check one more for loop. When you use a for loop inside other for loop, then this is called nested loops. In general, if you use a loop inside other loop, then this is called nested loop. So one for loop is under the influence of the outer for loop. So here we are using nested for loops. B equals to 1 because factors starts from 1, any number, suppose 7, then obviously 1 is a factor of 7. And to be a prime, there must be only 2 factors. And j should be less than or equal to I, and this j must be increased every time. Thereafter there will be condition. Condition will be I %j equals to 0. This means that I is divisible by 0. Then we have to increase the count. This count will be increased. Initially it is 0. Okay. And this will be 1. When it will be 2, then obviously we will get a prime number, because prime numbers have only 2 factors. So we have to write again the condition: if count is equals to 2, then obviously there will be 2 factors, and when there are 2 factors of a number, then that will be a prime number, and obviously we have to print the same, so we use the printer function. %d \t to print at a tab distance, and thereafter I. An important thing is that when you get a prime number, then you go for the next prime number. To work on the next prime number, you have to go through the same process. So when one process is complete, then you have to keep the count again equals to 0. So I type count equals to 0, because in C program a variable may change. To I have already uploaded at least 2 videos regarding this. You can review those programs. Let us run. Okay, it is showing some error. Here you see, here after num there will be a semicolon, and here will be I plus plus. Okay, now see, yes, it is asking for the number. Suppose I am entering 5. Oh, okay. You see, we got 3 numbers, 2, 3 and 5, which are less than or equal to 5, and also these are prime numbers. Suppose we are entering another number. This time, suppose I entered 65. Then you can see these are prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61. These all are prime numbers which are less than 65. In this way, you can enter any number and may get prime numbers equals to or less than that number. Okay, thanks.